This is part 2 of the Unit 8 Pre-AP test review. In the first video I did problems 1 through, I believe it was 13. So in this video I'm going to finish it up by starting with 14 and going to the end. Alright, so in 14 it says two wooden blocks of the same size are angled toward each other on a floor such that the angle between the two blocks is 32 degrees. What is the value of x at the measure of the angle between the block and the floor? Record your answer on your answer document. Be sure to use the correct place value. Okay, so this is telling me that these two blocks are the same size, which is an important detail because that means that this side would have to be the same as this side, which makes this an isosceles triangle. I know the angle up here between the blocks is 32 degrees, and what I'm trying to find is this angle down here. Since these two sides are the same, I know that these two angles are also going to be the same. So if this one's x, then this one here is also x. So both of these are actually x. Okay, so I don't know anything about the angles that are equal to each other except that they're the same and they're both x. So I can't really write an equation using that detail, but I do know that the angles in a triangle equal 180. So I know that if I add it 32 degrees, this one, plus this one down here, which I'm just going to have to say is x since I don't know it, plus this one right here, which is also x, that together these three angles would equal 180 degrees. All right, so then to go ahead and solve this, I want to simplify by adding my x's together. So this is like having a 1x plus another 1x, which is just 2x's, right? So this is 32 plus 2x equal to 180. And then I'm going to solve it by cutting it in half. Doing the opposite of adding 32 would be subtracting 32. That gives me 2x here. 180 minus 32, I'm going to have to borrow 10 minus 2 is 8, 7 minus 3 is 4, and then I'm going to bring down my 1. So 2x equals 148. Now if I continue by dividing by 2, x is going to equal 74. So that tells me that both of these angles are 74 degrees, so x is equal to 74 degrees. Another way to think about this problem is to say, all right, well I know this angle, so if I took 32 away from 180, then that would give me 148, and then I know that's what's left between these two angles, and since they're the same, I have to split that between the two. So I would end up dividing 2 into 148. Again, just a different way to think about the same problem, but you get the same answer. All right, in 15, it says if the diameter of a circle is 20 inches, what is the radius in inches? So if I drew a picture of a circle, diameter is the whole way across. So d is equal to 20. And then I just want to know the radius. The radius is halfway across. So what's half of 20? 10. So 10 inches. All right, on 16, it says find the circumference of the circle. Use 3.14 for pi. So I know my circumference formula is pi times diameter. And if I look at the circle here, I can see that the diameter has been given to me. It's 5 centimeters. And they tell me to use 3.14 for pi, so I'm just going to multiply 3.14 times 5, the diameter, and then that should give me the circumference. So 5 times 4 is 20, 5 times 1 is 5, plus 2 is 7, 5 times 3 is 15, 2 decimal places, so 15.70 or just 15.7. This would be in centimeters, so my circumference is 15.7 centimeters. All right, in 17, it says find the circumference of the circle. Use 3.14 for pi. So again, I'm finding circumference. Now, there are actually two formulas for circumference, pi times the diameter or 2 pi r. It really doesn't matter which one you use. You get the same one anyway. Personally, I like pi times the diameter because to me it's easy to double the radius and get the diameter. But you could use either one. So if the radius is 6, that tells me if I went all the way across, that would be another 6. So the diameter would be 12 if the radius is 6. So if I use this formula, I would multiply 3.14 times 12. Okay, if I'm using this formula right here, I'm doing 2 times 3.14 times 6. Again, it doesn't matter. Choose the one you like to use. So I'm going to use this one. So I only have to multiply once. 3.14 times 12. 4 times 2 is 8, 2 times 1 is 2, 2 times 3 is 6. Start with a 0, 1 times 4, 1 times 1, 1 times 3, and add those at 8, 6, 7, 3. And then there's 2 decimal places, so that gives me 37.68. for the circumference, and then this is being measured in centimeters. So this is my answer, 37.68 centimeters. 18 says find the area of the circle. Use 3.14 for pi. So I know the formula for the area of a circle is A equal to pi r squared. So pi is 3.14. They've given me the radius. The radius is 8 here. I need to do 8 to the second power. So I'm going to do exponents before I multiply. So 8 times 8, that's what this exponent means, is going to give me 64. So now I'm going to multiply 3.14 times 64. 4 times 4 is 16. 4 times 1 is 5. 3 times 4 is 12. Start with a 0. 4 times 6 is 24. Carry your 2. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. That would be 6, 9, 10, 10, 2. And then there are 2 decimal places here, so 2 here. So I can say my area is 200.96, and this is being measured in centimeters, and it's actually square centimeters because it's area. Right? So I can use this exponent to identify square centimeters, or I could write square centimeters like that. Okay? All right, moving on. 19 says find the area of the semicircle with a radius of 8 inches. Use 3.14 for pi. Okay, so it says here that the radius is 8, but here it says the diameter is 10. So I'm going to pretend this is not here. I'm not really sure which one is correct, but I'm going to go with 10. So if the diameter is 10 centimeters, then the radius is 5 centimeters. All right, and so if I use my formula, A equals pi r squared, then I'm going to do 3.14 times 5 to the second power. So 5 times 5 would be 25, so I need to do 3.14 times 25. If I do that, 3.14 times 25, I'm going to get 27, let's see, 15. All right, and then if I start with a 0, 4 times 2 is 8, 2 times 1 is 2, 2 times 3 is 6. So 0, 15, 8, and 7. 2 decimal places gives me 78.50, or just 78.5. And then this is actually a semicircle. So this is the area of the whole circle. If I had the complete circle, this would be my area. Since I'm only doing the semicircle, that's half of the circle. So I need to take this answer and divide it by 2. So I'm going to go ahead and do that. 2 into 78.5. 2 will go into 7 3 times. I subtract 6 and get 1. Bring down the 8. 2 will go into 18 9 times. Subtract, bring up my decimal, bring down the 5. 2 will go into 5 2 times. When I subtract 4, I'm running out of room. I'm going to have to bring down a 0, so 2 will go into 10 5 times. All right, and so the area of the semicircle would be 39.25, and this is also in square centimeters. Okay. Number 20, it says the circumference of a top of the circular table is 28.26 centimeters. What is the area of the top of the table? Use 3.14 for pi, round to the nearest whole number. Hint, the circumference of a circle is c equals 2 pi r, where r is the radius. All right, so in this problem, they're telling me the circumference, but they're asking for the area. So in order to find the area of a circle, I have to do pi r squared. So if I don't know the radius, that's going to be hard to do. So what I have to do is use the circumference to find the radius. So I know from the hint that c is equal to 2 pi r. The circumference they give me is 28.26. This is 2 times the radius. 2 times pi is 3.14. And then times the radius, like that. Okay, so I need to solve for r. So I'm going to first simplify this part. So I'm going to go ahead and multiply 3.14 times 2 is 6.28. So now I have 28.26 equal to 6.28 r. If I cut that in half and divide by 6.28, then going to have to move my decimal over. More fox and rabbit. All right, so this becomes 628 into 2,826. So I can't divide 628 into 282. I can divide it into 2,826 4 times. 4 times 8 is 32. Carry your 3. 4 times 8 is, or 4 times 2 is 8 plus 3 is 11. Carry your 1s. 4 times 6 is 24. Plus 1 is 25. So I was trying to do that in my head, but if you're not sure, 628 times 4, 32, 11. Yeah, that's right. Okay, so I'm going to subtract 4, 1, 3, and then I need to keep going because I still have to find the radius. So I'm going to add a decimal and bring down that 0. So 628 will go into 3,140. I'm going to try 5 times. So if I did 628 times 5, it's 40, 14, 31. Yay! All right, so 3,140. So that tells me the radius is 4.5. And I might like to be done at this point, but I haven't answered the question. The question is, what is the area? So now I'm going to use that in this formula. Pi is 3.14, and then I have to square 4.5. Okay, so now I have to multiply 4.5 times 4.5. So 25, 22, start with a 0. 4 times 5 is 20, carry your 2, 16, 18, so 5, 2, 10, 20. And there are 2 decimal places, so 20.25. So now I need to multiply 3.14 times 20.25. All right, almost done. I'm going to use 20.25 on top because it has more digits. I like multiplying that way. So 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 0 is 0, plus 1. 4 times 2 is 8. Start with a 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 0 is 0. 1 times 2 is 2. Start with 2 zeros. 3 times 5 is 15. 2 times 3 is 6, plus 1 is 7. 3 times 0 is 0. 3 times 2 is 6. Add these up. 0, 5, 8, 15. 3, 6, and there are 1, 2, 3, 4. So 1, 2, 3, 4 decimal places. All right, so 63.5850 is my area. It does say round to the nearest whole number. Whole number would be my ones place, so that's going to round up because this is a 5. It's going to round this up to 64. So the area is 64, and it's being measured in centimeters, so this would be square centimeters. All right, so just kind of to review what we did, we knew the circumference, so we had to use that to solve for the radius. And once we knew the radius, we could plug that into the area formula and then just solve it. So don't give up on that one. It's just a little longer than the normal problem. All right, on 21, it says find the area of the figure. So this is not one of my normal shapes, but I can divide it into 2 shapes that I do know. And so that's what I'm going to do. So if I make a cut right here, you can see that I actually have 2 rectangles. So one of my rectangles, this long one, is going to be the base times the height. So I would do 5 times 3, which would give me 15. All right, and then if I did this little rectangle going this direction, and this part is 2, I can't use 6 because I cut off part of it. So I know if this part was 3, then that leaves 3 for this part. So this area of the smaller one would be 2 times 3, which is 6. And then if I want the area of the whole figure, I add those 2 together. So 15 plus 6 would be 21, and is being measured in feet. And so that would be 21 feet squared. Okay? And you could also cut it this direction. You don't have to go this way. So if we went this way, it would be 2 times 6, and then this one would be, what would that be? 3 times 3. Same answer. All right, number 22. Find the area of the figures. I can see I have a rectangle and I have a trapezoid. So the area of a rectangle, a rectangle is base times height. So for this rectangle, the base and the height are 8 and 4, so that would be 32. And for the trapezoid, the formula is 1/2 base 1 plus base 2 times the height. So I'm going to do 1/2, and the bases, remember, are your parallel sides. They also are the ones that make this right angle with the height. So I'm going to add 8 plus 14, and then multiply times the height. Height has to be straight up. Remember, you don't lean over when you're getting measured. So this would be times 4. All right, I'm going to start by adding those together. 8 plus 14 is 22 times 4. All right, and so here, because multiplication is commutative, I have a choice. I can either multiply 22 times 4 and then divide by 2, or I can go ahead and take half of 22 and then multiply by 4. I like to do half of 22 first because it gives me something smaller to multiply by. Half of 22 is 11. 11 times 4 is 44. And this is in feet, and it's area, so it's square feet. So the area of these two combined is 44 square feet. All right. Oh, hang on. Ooh, I almost messed up. Okay, so that's the area of the trapezoid, but I didn't actually combine it with the area of the rectangle, so my bad. Don't circle that. All right, so now go back and add the rectangle plus the trapezoid. So 44 plus 32 would be 76. That's the combined area, and it's in square feet. Okay. Sorry, hope I didn't confuse you. Last 2 problems. So again, we're finding the area of this combined shape. So here I have a triangle. Here I have a trapezoid. It's kind of turned over. It's still a trapezoid. So in a triangle, the formula is 1/2 base times height. It's good to look up these formulas and write them down every time you use them. That way you don't forget those little halves. So for this one, the base and the height of this triangle, it would be 4 and 3. So I'm going to do 1/2 of 4 times 3. All right, so if you use that trick from before, if I do half of 4, that's 2, and 2 times 3 is 6. Okay, or you can do 4 times 3 is 12, and then take half. Same thing. All right, trapezoids are going to be 1/2 base 1 plus base 2 times the height. So for this trapezoid, I'm going to do 1/2. The bases are 10 and 6. So 10 plus 6. And then the height is making this right angle here, so 2. All right, so 10 plus 6 is 16. Then I can do half of 16, which would be 8. And 8 times 2 is 16. All right, so that's the area of the trapezoid. And then I want the combined area, so now I'm going to add 16 plus 6, which is 22. So the total area would be 22. And this is being measured in meters, so this would be square meters for area. All right, 24 says determine the area of the shaded region and the composite figure shown below. All right, so this is one of those where you start with a big and then they've cut out a piece of that original shape. So I still need to know the area of both of these shapes, but instead of adding them together and getting something larger, I'm actually going to subtract because they took away part of the shape. So the big shape, the overall big shape, is actually a trapezoid. Okay, it's just been turned sideways. So I'm going to use, for the trapezoid, same formula I've been using, 1/2 base 1 plus base 2 times the height. My bases are actually on the sides this time, but you can see they're still the parallel sides. So 1/2, 12 plus 6, and then the height is going to be this part. It's the straight part. So it's this whole thing, which is 6 plus 6, which would be 12. All right, so if I add 12 plus 6, I get 18 times 12. If I do half of 18, that's 9. And then if I did 12 times 9, I would get 108. All right, so my area for the trapezoid is 108. Then I still need to find the area of the triangle. So 1/2 the base times the height. So for this triangle, it's 1/2 of the base is this, again, this whole thing. You don't have to divide this into 2 triangles. You can just do the area of the whole triangle. So together, if I do these all together, this whole base is 6 plus 6, which is 12. And then the height is 6. So if I do half of 12, that's 6. And then 6 times 6 is 36. Okay? And so again, this was cut away from the trapezoid. So instead of adding, I'm going to subtract. So 8 minus 6 is 2. And then 10 minus 3 is 7. So the area of the shaded part is 72. And that little double apostrophe there stands for inches, and this is area, so it's going to be square inches. Okay, that's the end of the pre-AP test review. So hopefully that's helpful to you, and I'll see you tomorrow.